Okay, so onwards with our final problem here for triangles. So the final problem is actually an enrichment. Just like what we had for polygons, we had mathematical induction proof. Okay, so we're not going to use much of mathematical induction when we're trying to prove concepts here in geometry. Mathematical induction is mostly used in number theory. Okay, but for geometry, what we're going to use is deductive proof. Okay, so deductive proof, you might have heard it from investigation films, from crime-related films. Okay, so we also do that in geometry. Okay, but for here in geometry, it's much more formal. We're going to use theorems and postulates and definitions to prove our theorems or the problems or the mathematical statements that we want to prove. So the first one that we want to prove here is the triangle angle sum theorem. The sum of the measures of an angle of any triangle is 180 degrees. Okay, so have you ever wondered why is it 180 degrees? Why not 360? Why not 540 degrees? Or why not any type of number? So why is it 180 degrees? Why does the sum of the measurement of the angles of a triangle have to equal to 180 degrees? So we're going to discover that theorem today. We're going to prove this theorem today using simple synthetic geometry. So there's no measurement. We're not gonna use any type of measurement. We're just going to simply use our deductive reasoning and follow our deductive reasoning to come up with a proof for this theorem. Okay, so we want to prove given angle CAP. Okay, so given here triangle CAP, we want to prove that the measurement of angle C plus the measurement of angle A plus the measurement of angle P, or the measurement of the three angles that we have there in the triangle, is equal to 180 degrees. So we need to have a plan. Okay, so what do we need to do in order to prove this theorem? To prove that the triangle angle sum theorem is true using deductive proof. So what we're going to do here is we have to create a line, and not just any line. This line has to be parallel to line CP, the one that's on the bottom. So we're going to create a line. We're going to name it line SM. So line SM has to be parallel to line CP. So you really have to think outside the box when it comes to these kinds of theorems. Okay, so first, of course, line SM was not given. Okay, but you need to think outside the box in order to prove these kinds of theorems. Okay, so we have here line SM. We drew line SM there, and it's parallel to line CP. And then and then we formed two angles. Okay, so we formed angle 1. So angle 1 is kind of like here on the top of the triangle, and then we formed another angle, angle 2. Okay, so the plan in order to prove that the measurement of this triangle is 180 degrees, we need to, of course, what we did there is we constructed a parallel line to CP. So this is the illustration. So that's line SM, and it's parallel to line CP. And after that, we can say that angle C, the measurement of angle C, is congruent to the measurement of angle 1. Okay, and the measurement of angle P is congruent to the measurement of angle 2. So how can we do that? How can we say that? So that's the alternate interior angles. Okay, so alternate interior angles, when they are cut by a transversal, so they are the same. Okay, so since they're the same, the measurement of angle 1 is equal to the measurement of angle angle C, and the measurement of angle 2 is the same as the measurement of angle P. Okay, so that's the plan there. And then we have to then substitute the measurement of these two angles. Okay, so the measurement of angle 1 plus the measurement of angle CAP plus the measurement of angle 2 has to equal to 180 degrees. Okay, so this is the proof. Okay, this is the proof of how to do it. So first, you have here on your left side, you have your statements, and on the right side, you have here your proofs. So how do we do this? First, we state your first statement. Through A, construct a line SM parallel to CP. And the proof for that through a point, not on a line. There is exactly one line parallel to the given line. And then for number 2, we have here angle SAP and angle 2 form a linear pair. So angle SAP and angle 2, yes, form a linear pair. So that's the definition of a linear pair. So that's how you do it. So you provide a statement and then you provide the proof for that. And then you have angle SAP and angle 2 are supplementary angles since they are linear pairs. And then for number 4, we have the measurement of angle SAP plus the measurement of angle 2 is 180 degrees. So that's the definition of a supplementary angle. Therefore, we can say that the measurement of angle SAP is equal to the measurement of angle 1 plus also the measurement of angle CAP. So that's the angle addition postulate. So from substituting those two values, so we get the measurement of angle 1 plus the measurement of angle CAP, since that measurement is added to the measurement of angle 2 is equals to 180 on number 4. So the measurement of angle, for number 6, we have the measurement of angle 1 plus the measurement of angle CAP plus the measurement of angle 2 is equals to 180 degrees from substitution property of equality. Now, are we going to finish here? Okay, so we're still not going to finish here because what we want to prove is the measurement of angle C, angle A, and angle P are equal to 180 degrees. So how do we do that? Okay, so we use the plan that we had a while ago. We have their angle 1 and angle C are congruent, and angle 2 and angle P are also congruent because they are alternate interior angles. So when they are cut by a transversal, since we created a parallel line, and when that's cut by a transversal, so the alternate interior angles are the same. Okay, and also of course their measurements. Okay, so the measurement of angle 1 is congruent to the measurement of angle C, and the measurement of angle 2 is congruent to the measurement of angle P. And then lastly, we use the substitution property of equality. Since the measurement of angle CAP there is equal to the measurement of angle A, then we can say that the measurement of angle C plus the measurement of angle A plus the measurement of angle P is equal to 180 degrees, okay, from the substitution property of equality. And there you go. So using deduction, using the deductive proof that we have, by constructing a parallel line, we were able to prove that the measurement of the angles of a triangle is really 180 degrees. Okay, so we really had to think outside the box when it comes to these problems. Okay, so that's the conclusion right there. If figure CAP is a triangle, then the measurement of angle C plus the measurement of angle A plus the measurement of angle P is equal to 180 degrees. Okay, so we have here 4 corollaries. So this corollaries are the subparts of the theorem of the triangle angle sum theorem. So if 2 angles of one triangle is congruent to the 2 triangles of a second triangle, then the third angle of both triangles are congruent. Okay, so let's say for example we have there 2 triangles. Okay, so let's draw. So we have here triangle A. Okay, triangle A, and then triangle B. Okay, so what this corollary 1 states is that if the side here, if the sides here of triangle A is the same as the side here as the triangle B, then this third side of triangle A and B are also the same. Okay, then for corollary number 2, each angle of an equilateral triangle is 60 degrees. Okay, that's given. Corollary number 3, in a triangle there can be at most one right angle or at most one obtuse angle. Okay, so like what we discussed in the introduction of triangles. And lastly, number 4, corollary number 4, the acute angles of a right triangle are complementary. So what does that mean? So for example, we have here a right triangle. So let's name that right triangle ABC. Okay, so for triangle ABC, let's say for example angle B is the 90-degree angle. Therefore, this angle right here and this angle right here are complementary angles. And the definition of a complementary angle, okay, they are a pair of angles whose sum is 90 degrees. Okay, So that means, for example, if this is 45 degrees and this 45 degrees, then their sum is 90 degrees. But what this also says is that since the measurement of the right angle is 90 degrees, we can deduct that or subtract that from 180 degrees, the measurement of the angle of a triangle. So 180 minus 90, you get 90. And of course, that's the definition for a complementary angle. So these two angles right here, angle A and angle B, whatever their measurements are, will always be equal to 90 degrees if you add them, and therefore they are complementary angles. So that's it for triangles. Thank you for listening, grade 8 Makati Science High School students.